This is a video answer key of an activity we did called Pac-Man with gases. And it's just designed to help you in case you need a little extra help with this activity. Let's get started. A gas of initial pressure of 1.5 atmospheres, so I'm going to put pressure 1 equals 1.5 atmospheres at 25 degrees Celsius. So temperature 1, now remember you have to add 273 to that to get in the Kelvin, so that's 298 Kelvin. Determine the new pressure, so I'm going to say pressure 2, that equals a question mark, at 50 degrees Celsius. So temperature 2, remember to add 273 to that, is 323 Kelvin. So I'm going to look at my variables. It looks like I've got pressures and temperatures. So I look at my equations that we've gone through. It looks to me like that's going to be Guy-Lussac's law. P1 T2 equals P2 T1. So here I go. I'm going to put 1.5 in where I see pressure 1. So 1.5. Temperature 2 is T2. So I'm going to put that where I see T2. That's 323 equals P2. We don't know that one. So I'll say P2 there. That's one we're trying to solve. And then T1 is right there, so 298 goes there. All right, now mathematically, what am I going to do? I need to get P2 by itself. So I'm going to divide by 298 on both sides to get P2 all by itself. So then mathematically, I'll take 1.5 times 323. Divided by 298, and that should give me an answer of 1.6, and that's what you'll enter into the simulation. You will not record any variables with that, and we're rounding to the tenths place, so that's 1.6 atmospheres, but don't write atmospheres with that. Okay, I'll let you try the second question. If you want to pause the video and try it. Okay, assuming that you paused the video, let's take a look at the second question. Initial volume of a gas is 35 milliliters at 44 kilopascals. So pressure 1 is going to be 44, and that's kilopascals. Volume 1 is 35 milliliters. Determine new volume at 25 kilopascals. So pressure 2 equals 25 kilopascals. And we're determining volume 2, and that's our question mark. So I've got pressure and volumes this time, so I'm looking at my equation list. Here's Boyle's law right here. P1 V1 equals P2 V2. So then I'm going to put 44 for my pressure 1 right there. Volume 1 is 35, so I'm putting 35 right there. Equals pressure 2, I know that, 25. And I'm solving for V2, the final volume. Now again, I need to get my variable by itself, so I'll divide both sides by 25 to get V2 by itself. So mathematically, I'm doing 44 times 35 divided by 25, and that'll give me 61.6, and again that's going to be milliliters because that's what my volumes are measured in. Okay, and again you'll just record 61.6 into the simulation. So all of these, follow this pattern. Okay, hopefully this is helping you. If we look at the next two questions here, I've got a question here with an initial volume and initial temperature. So let's go ahead and record those. Initial volume, V1, equals 2.4 liters at 35 degrees Celsius. So temperature 1, we do need to add 273 to that. That should give us 308 Kelvin. Determine the new temperature at 3.5 liters. So V2 equals 3.5 liters. And temperature 2, okay, is what we're trying to figure out. All right, I've got a volume and temperature variables this time. So volume and temperature, that would be Charles' law. This is the only equation that has volume and temperatures in it. So this is going to be different though. We're going to multiply volume 1 times T2 equals volume 2 times T1. Okay, so volume 1 is 2.4 liters. Okay, and we're trying to find T2, so my variable will be on the left side this time, equals 3.5 multiplied by 308. All right, now mathematically, what am I going to do? I need to get T2 by itself, so I divide by 2.4 on both sides. So divide by 2.4. So 3.5 times 308 divided by 2.4. And that'll give me the answer of 449.2. And that's what you'll record in the simulation. And the answer for this is actually in Kelvin already. So you don't need to convert this one to Kelvin. It comes out as Kelvin already because we used the equation already. All right, let's move on to the next question. An initial temperature of a gas is 45 degrees Celsius. Pressure 95 kilopascals and volume is 85. It looks like I'm using all the variables this time. So pressure 1 is equal to 95. And again, I'm recording my units when I do my little chart. Volume 1 is 85 liters. Temperature 1, I have to add 273 to that, so that's going to be 318 Kelvin. Find the new volume at 75 degrees Celsius and 101 kilopascals. So pressure 2 equals 101 kilopascals. And looks to me like we're determining volume 2. So that's going to be our question mark. And then our new temperature, temperature 2, we have to add 273 to that. That is 348 Kelvin. Okay, now I've got all three variables, so that's going to be our combined gas law. So I'm going to check that one off there and scroll down a little bit so we can do this question. I've got pressure 1, volume 1, temperature 2. So it's going to be P1, V1, and temperature 2 all on the left side. So 95 multiplied by 85 times 348 equals pressure 2, volume 2, temperature 1. Notice again how T2 and T1 are always backwards there. Okay, so that's going to be 101. And then again, I've got volume 2, which I don't know what it is. Okay, and then T1, which is 318. Now I've got to get V1 by itself. It's kind of nestled in there. So I need to divide both sides. Now here's the key thing. In your calculator, put a parenthesis, and then a 101, and then hit the times button, and then 318, and then close the parenthesis. Likewise on this side here. 101 times 318 and close the parenthesis. So mathematically I'm going to do 95 times 85 times 348 divided by, open my parenthesis, 101 times 318, close parenthesis, hit equals. End up with 87.5. And that looks to me like it will be a liter's value because that's what we had initially listed there. Well, hopefully this is making good sense, and we will just quickly finish the remaining three. The pattern doesn't change at all. We're just putting numbers into equations. In this one here, we've got an initial volume, and it looks like the pressure is 85 kilopascals. So I'm going to put P1 equals 85 kilopascals. Volume 1 equals 64 milliliters. Temperature 1 is 25 degrees Celsius. Again, have to add 273 to that, so that's 298 Kelvin. Over here, pressure 2, okay, is 101 kilopascals. We're trying to find volume 2, so that's our question mark. At 0 degrees Celsius, so temperature 2 is going to equal 0 plus 273, which is 273 Kelvin. Okay, and this is a K here also. All right, so we're going to set this one up. It looks like, again, a combined gas law. So let's go ahead and set that up. I don't have much room this time. Okay, so we'll see. Actually, I'll put it here, and then I can extend the other question down there. Okay, so it'll be 85 times my volume 1 of 64 times my temperature 2 of 273 equals 101 multiplied by volume 2, which is our variable we're trying to find, multiplied by 298. Okay, now I got to get V2 by itself. So I need to divide both sides. Now again, because I've got more than one number here, I do need a parenthesis that. 101 and then times 298. So I'm going to divide this whole side by, again, parenthesis, 101 times 298. So mathematically, 85 times 64 times 273 divided by open parenthesis 101 times 298 close parenthesis. And I should get 50.1. And my volume is actually in milliliters. But remember, in the simulation, do not record milliliters. All right, let's quickly go through two more questions here. Okay, and let me scroll down here a little bit. We have initial temperature of 35 degrees and volume of 6.4. So volume 1 equals 6.4 liters. Temperature 1 is in degrees Celsius. We have to add 273 to that. That's 308 Kelvin. And determine new temperature. So volume 2 equals 2.6 liters. We're determining new temperature. So that's T2. So that's our question mark. So that is we have a volume and temperature again, back to Charles' law. I'll check that one there. This is the equation we're going to use. So 6.4 multiplied by T2, we're trying to find T2, equals volume 2, which is 2.6. So we're going to multiply that by temperature 1 of 308. All right, now mathematically, I just have to divide both sides by 6.4 this time in order to get temperature 2 by itself. So divide by 6.4. So I'm going to take 2.6 times 308 divided by 6.4. And that gives me 125.1. Now remember, that answer does come out as Kelvin. So hopefully you like this form a chart method. I always include all of my units to make sure that the units are the same. Sometimes in questions they might give you Kelvin here and degrees over there, or liters and then milliliters. Now I'm not doing that to you right now, but it's a good idea to always form a chart. All right, and let's get our last question done. So initial volume is 73 milliliters at 75 kilopascals. So pressure 1 equals 75 kilopascals. Volume 1 is 73 milliliters. Determine new volume at a pressure of 101 kilopascals. So volume 2 is our question mark. So we're dealing with pressure and volume only. So that is Boyle's law. So I'm going to take 75 times 73 equals 101 times V2. And then mathematically, all I'm going to do there is divide both sides by 101. It's only the combined gas laws where you have to do parentheses. Okay, so 75 times 73 divided by 101 gives me 54.2, and that's a milliliter volume. So again, do not record that in the simulation though. Okay, hopefully that does help. And you're getting the ideas down. Of course, you do need to recognize temperature values. Temperature is degrees Celsius, but must go into Kelvin. Volumes are typically milliliters and liters. And pressures are typically atmospheres and kilopascals. So you do need to know that when you see a kilopascal, that's a pressure. A liter is a volume, of course, and Kelvin and Celsius are temperatures. Hopefully it does help. And I will be making more videos to help you guys out.